Power, remember, is correctly detecting a treatment effect. On the, when we did the HO and HA curves overlapping one another, the probability of correctly detecting a treatment effect was 1 minus beta. Do you remember that? We want to have a lot of power in our tests. We want to have a really good chance of correctly detecting treatment effects. So all things considered equal, which type of two-way ANOVA is going to be the most powerful? Well, you learned previously that if we have a within subjects factor, or it could be a matched factor, right? We could have done matching. But if we have that kind of factor, we can reduce the error term. Remember that? By using a within subjects factor or using matching on a relevant extraneous variable, we can make the error term smaller, which will increase the value of F, right? We're increasing the value of our test statistic. And our test statistic in ANOVAs is the F value. That's our test statistic. So anytime you have both factors as within subjects, you're going to be able to reduce your error term by removing individual variability, right? We talked about being able to remove individual differences from your error term. That's what makes the error term smaller. So if you have both factors as within subjects or matched on a relevant extraneous variable, you should get the lowest error term, which means you're getting the highest F value. That's going to give you the most power. The one with the least power would be this two-way independent, because both factors are between subjects, which means you don't get to remove individual differences from your error term. The error term in a two-way independent is going to be the highest. So if this analysis has the highest error terms, it's going to give you the lowest F values. So you're going to have the least amount of power here. Now the two-way mixed is in between, because you have one factor that's within, so you can remove individual differences from that error term, but the other factor is between subjects. So you're going to have a low error term for the within subjects factor and a higher error term for the between subjects factor. That puts you right smack dab in the middle, okay? So it's kind of like, it's in between.